Okay, welcome to this session on the M.Tech in Systems Engineering. My name is Professor Bhaskar, and I am the head of mechanical engineering. And today we have Professor Debasis Chakraborty, the professor in mechanical engineering, who will be talking about the M.Tech in Systems Engineering. Okay, so before we get into the M.Tech, let me give a brief background of our MU, Mahindra University. Our chancellor is Sri Anand Mahindra. He is the chairman of Mahindra and Mahindra Group. And our vice chancellor is Professor Meduri Ajulu. We have two deans. Professor R.A.K. Bhattacharya is the Dean for R&D Research and Development, while Professor Vishnupal is Dean of Academics. Right. So looking at the evolution, Mahindra Equal Central, that was the initial institute, was established in 2014. So it has been 8 years since the institute has been running. Initially it was a collaboration between Mahindra Group, Equal Central Paris, which is the IIT equivalent in France, and the JNTU Hyderabad. We were offering only the traditional 4 programs of computer science, civil, electrical, and mechanical engineering. So in May 2020, we became a private university. So it's now the Mahindra University, but which has different schools. There is the School of Engineering, which still has the collaboration with Equal Central and is called the Equal Central School of Engineering. Then we have School of Management, School of Law, School of Higher Education, School of Management. Okay. So the purpose of, so once we became a Mahindra University, we looked at the definition of the entire program at Mahindra University. And the purpose is to educate future citizens for a better world. And the mission is to train multi-skilled leaders, look at interdisciplinary academic excellence by integrating science and technology with humanities, ethics, and philosophy, and then balance education with experience, right? The key is to have the basics and applications taught through classroom lectures, but the application part would be through hands-on experience with the actual products. Okay, so this is our entire campus. So you can see here this building right now. So the main entrance right now is here. So as you come along, take a right and then the left, and come to the Equal Central School of Engineering. There are the hostel blocks, and we have the other schools coming up around here. Okay, so it's a huge campus, 100+ acres. So right now, under Equal Central School of Engineering, this is a collaboration with the Central Super League. We have 12 undergraduate programs, and then 7 M.Tech programs, and then we also have PhD. So today we'll be talking more on the Systems Engineering Master's program. So what is the key advantage of being with Mahindra University is all our faculties are from have PhDs, and they are from PhDs with in IITs or abroad, and most of them also have postdoctoral experience in abroad, like in France, UK, and US. And then a lot of us have industry experience, so that helps to correlate and provide examples of academics with industry applications. Then entrepreneur learning. So it's how to take an idea till product. That's something you're looking at if you want to go as an entrepreneur and do your own startup. Then there are global academic partnership like with the Bobson College. Then we actually, as a part of our board of studies, which goes through the curriculum, we have both academic and industry experts who actually look at the curriculum and suggest what will help the industry, right? So that the students are industry ready. And of course, the state-of-the-art infrastructures in different center of excellence, right? So this is a brief overview of Mahindra University. With this, I will hand over to Professor Debasis Chakraborty, who will be talking about the M.Tech program on systems engineering. Right. Professor Debasis, please take over.
Thank you. Is okay now?
Yes, yes. Please go ahead.
Okay. Let me introduce myself first. I'm Debasis Chakraborty. I worked in Vikram Sarabhai Space Center, ISRO, and Defense Research and Development Laboratories, Hyderabad. And for nearly 33 years, then last 2.5 years, I was working as a professor in IIT Bombay in Aerospace Engineering Department, also as the director of the Center of Propulsion Technology. And I have joined Mahindra University, and we are jointly pursuing this development of this course on system engineering. The presentation outline is as follows. I'll be talking about what is the system, and what is system engineering, and what is the difference between the traditional engineering and the system engineering. What is the role of system engineering processes, system integration, verification and validation, system engineering applications. Then one international society is there, which is guiding the activities of the system engineering, called INCOSE. I'll give little details about it. Then finally, I'll be giving the details of the system engineering course of Mahindra University. We'll talk about eligibility, course outline, course objective, course facilitators, learning objectives, and job opportunities. This is the outline of the presentation. Now, what is a system? This is a purposeful collection of the interrelated components working together to achieve some common objectives. It may include software, various engineering discipline, mechanical, electronics hardware, and they're operated by people. System components are dependent on other system components, and the properties and the behavior of the system components are inextricably intermingled. There are two categories of the system. One, first we call it technical system. This is that include hardware and software, but they don't include the people who operate it. And another one is a socio-technical system, that they include technical system, but also operational process, and the people who use and interact with this technical system are also included in this class. So mostly we'll be talking about the socio-technical systems. Systems are not dependent but exist in an environment. Systems function maybe to change its environment. Environments affect the functioning of the system, the organizational as well as the physical environment. That is important. This system requires the changes to the work processes in the environment. How will we understanding a system? The way in which it will be used, the environment in which it will operate, and the knowledge, technologies, and the methods that go into making it. For a wide range of engineering applications, this problem is quite tractable. However, as system becomes more complex, we need to be strategic in the way we approach design. There is the point of importance. We have to simplify the design. We have to simplify the decision making in design, and we have to do the formal analysis. Our understanding of the system behavior need to be right. Now, if you look at that thing to understand of a system, original system will be very much complex. We may not understand everything at the beginning. So we have to take the subsystem. Let us study the subsystem. In the subsystem, also in the component level, we will be studying. And initially, it will be too difficult to understand. If you remove the details, we can understand. And then again, we will come back to the system. This process we will be continuing. And what we need to know, what are the subsystem and how they are connected internally. How does this system interact with the surrounding environment? The system engineering, it is at the crossroad of the engineering and the business concerns. And there are system requirements, specifications, the constraints, that operational environment, and there are hardware elements, software element, human element. All those things will be integrated in the system engineering framework. So specific goal is to provide a balanced and disciplined approach to the total integration of the system building blocks with the surrounding environment, a methodology for the system development that focused on objective measurements, accomplishment. A system means to acquire more information and sort out and identify areas for trade-off in cost, performance, and quality. System engineering is a discipline that concentrates on the design and application of the whole system as distinct from the parts. It involves looking at a problem in its entirety, taking into account all the facets and all the variables relating to the social to the technical aspect. System engineering is an iterative process of top-down synthesis, development, and operation of a real-world system that satisfies in a near optimal manner the full range of requirements for the system. And it is an interdisciplinary approach. And we need to address the operation, cost and schedule, performance, training and support, test, manufacturing, and disposal. System engineering considers both the business and the technical needs of all customers with the goal of providing a quality product that meets the user need. To make these things, let us give an example. What is the application of the system engineering? We can understand the things better. This is a case of building a tunnel, a bridge, and within this island, which will be linking to Scandinavian countries, the Finland and Denmark, with the mainland of the Northern Europe. This is 8-kilometer bridge, 4 kilometers of tunnel, crossing the international navigation route between the Baltic and the North Sea. The world's largest composite structures, world's longest cable-stayed bridge carrying a 4-lane motorway, 2-track railway, highest freestanding bridge pylons, and the longest immersed concrete tunnel in the world. How the system engineering has been used to design this complex the project. And this design life is nearly 100 years, and construction time is exactly 4 years after starting from April 96. There are a lot of constraints. That is something on the maximum speed limit. The railway is 200 km per hour, motor 120 km per hour. Wind speed, which the bridge has to withstand, is around 61 meters per second. And there are other constraints. Wave height, because it will be going through sea. So the sea waves will be maximum height of 2.5 meters. The ice thickness of 0.6 meters, and temperature -27 to +27 degrees centigrade. That is the environment specification. And it has to accommodate to wide shipping lanes and zero sea traffic impact. This bridge should not have any impact on the sea traffic. And this budget is around $3 billion, which is translated to around 15,000 crores in Indian rupees. Extra challenges. This Denmark is having the right-handed the rail traffic system. Sweden is having the left-handed. So this connection must switch between the two as it comes to that particular country. Different railway power supply in two countries, and the salt levels in the Baltic Sea is different from the North Sea, supporting a unique ecologies on either side. And so that water exchange rate must not be reduced due to tunnel, bridge, and island. So that the presence of this bridge will not change the ecology of that system. And we have to synchronize the various disciplines: geotechnical engineer, aerodynamics, civil, mechanical, electrical, railways, traffic forecasting, risk analysis. All those things has to be done. And this project was successfully completed in 4 years. But before that, a 7-year design period were taken, with many iterative changes in the design and the impact analysis. This is one example. There are many examples, like the International Space Station was built, the use of system engineering, and the number of countries participated. People are going there, coming back, and also NASA is using this system engineering concept for many of its products. If you can look at the literature, you will be seeing multiple of the cases where the system engineering concepts were used, and what are the lessons learned they have documented. Coming back to the system engineering, it is a combination, as you have understood, this combination of interacting elements organized to achieve one or more stated purpose, an integrated set of elements, subsystem assemblies that accomplish a defined objective. These elements include, it may be product, process, people, information, techniques, facilities, service, and other support elements. There are concerns both in the design side and the management side. What is the required functionality? How well should the system perform? What about the cost and economics? How will functionally perform? And functionality will be verified and validated. And the management side, what purpose need to be placed to manage this development? What kind of support from management will be needed? And then we have to learn how to deal with this concern both in the design side and the management side. And we need to devise method to improve system performance and extend system functionally continuously. And now let us look at how the traditional engineering and the system engineering interact with each other. I think they are complement to each other. There is no clash. I mean to say, traditional system engineer need traditional engineering, and the traditional engineering also requires the system engineering. In the traditional engineering, we focus on knowledge generation, and that is we can create new technologies and new products. And the system engineering focus on understanding how existing technologies and things can be integrated together in new ways to create new product. So you can see the system engineering is interacting with various disciplines: software engineering, structural engineering, civil engineering, electrical engineering, business economics, user interface design, mechanical engineering. So any engineering discipline and the system engineering, they are continuously interacting with each other to really develop a product. And then the role of the system engineering, that is in the breadth, there are liaison of many disciplines. In the depth, we are having this thing, so the modeling and the simulation and the system tool networking. Then there also we have to integrate the finance, accounting, strategic planning. So engineering, computer hardware, and the business, they are integrated in the same framework. So the system engineering focuses on liaison among discipline and supported by formal methods for the system analysis and design. The system engineering process, we can have the requirement definition, system design, subsystem development, system integration, system installation, system evaluation, and the system decommissioning. So when a system, we have to plan how we will be launching a system, how you will be developing it, what are the subsystem, how to validate, and then finally we have to install it. And then when that service period is over, we have to plan for the decommissioning. That whole process has to be done in the system engineering. So this that same thing, the requirement specification, logical architecture, system design, physical system itself. And so these are the various models are there for the system engineering process. One of the simplest model is the waterfall diagram. And this works well when the problem and the solution methods are well understood and do not require large corrections. This little scope for iteration between phases, because hardware changes are very expensive, software may have to compensate for hardware problem. If the system is complex, generally we use a V model that is very popular in the system engineering process. And it was Forsberg and Moose, they proposed this model. And this model highlight the need for continuous validation with the stakeholders, the need to define verification plans during requirement and the development, and the importance of the continuous risk and the opportunity assessment. This V model has been used by NASA in many of their products. And this is one of the very, very popular model for the system engineering. And we need to do the system integration, verification, and the validation. And in the verification and the validation, we should ask the question whether are we building the right product or are we building the product right? So both the questions has to be answered, and this is the prerequisite for the customer acceptance. Validation and the verification concerns are a prerequisite for a product. And once the components are produced and validated at unit level, they are put together. The measure of the validation is the satisfaction of the unit specification. So there are various measures, and we will be dealing with these things in the system engineering courses. These are the various process in the integration, the validation. The subsystems are assembled and validated against corresponding specification. At each level of validating, testing, the test condition, the test procedure, and the expected outcomes have to be clearly stated. Then the system is assembled and the validated against the system specification. The system is then deployed and then tested for a period of time in the field. Finally, it is commissioned, that is, enters the commercial production mode. There are general life cycle stages: exploratory research, concept, development, production, utilization, support, and finally, the system has to be retired. That means they have to be decommissioned. So various purpose on the various stages are there, and the various decision options we have to take in the various stages of this product development. I'm just giving an example of an air traffic control system architecture. There are many components. You can have a radar system, transponder system, data communication system, aircraft communication system, telephone system, position processor, backup position processor. So the various components has to be integrated under the same framework. Then only aircraft can take off of the land and then have a accident-free journey. So this so many systems, if you have to integrate, there should be a method, and particularly the system engineering, this addresses those issues. There are many application domains of the system engineering. It is being used aerospace, automotive, urban infrastructures, communication, healthcare, financial system, educational system. Various major companies in US and abroad, particularly NASA, then aircraft companies, Airbus, Boeing, GE, Rolls-Royce, Pratt & Whitney, they are practicing system engineering in their product in many years. System engineering practices in automotives are in great demand. Healthcare, telecommunications, and the other sectors, they are increasing continuously in the recent years. We have just given one example of the joining two countries, that Ursan Bridge, but there are many other successful system engineering projects. Like International Space Station, we have told, the Tharak 25, the radiation therapy. What are the problem we faced? How we have solved? They're all well documented. That super high speed train in China, there was a prototype that was these things was executed through the system engineering project. Cyber security, incubators. So there are many examples are there in that things. I am not going into the details of the various examples, but those examples have given us very good lessons, and that these lessons we have compiled, and we are trying to do some this is a systematic evaluation of the various lessons, what we have learned from these case studies. That is, I was telling you that is an international council for the system engineering that is called INCOSE. It is this things regulating the effort of the system engineering. This is a profession, not for profit, professional bodies, and this is founded to develop, disseminate the interdisciplinary principle and the practices to enable the realization of the successful system. Its mission is share, promote, and advance the best of the system engineering from across the globe for the benefit of the humanity and the planet. Vision, the world's authority on the system engineering. And all this information is available in this website, www.incose.org. And INCOSE gives various certificates for the various levels of the people. For the student, they give that INCOSE ASF and the ASCP. And for those people who are having some experience, they are INCOSE CSCP. And those people who are experts in that system engineering, that certificate, they are giving it for the INCOSE ESCP. And various courses on the system engineering in India and abroad, they are there. And MIT, Georgia Tech, Cornell, Princeton, Pennsylvania, and the Bristol, Cranfield, many universities are offering these courses. In India, that the system engineering is gaining popularity. There was a system engineering course, Banaras Hindu University, that is emphasis in the control and the electrical engineering. Manipal Institute of Technology, this is an undergraduate level course on system engineering. And our Mahindra University, we are offering M.Tech course in the system engineering. And the details about the course, this is a 61 credit course, and this is offered to the students who are interested in their careers in the system engineering. And 61 credit is divided into 40 coursework, 40 credit in coursework and 21 credit in project work. And eligibility criteria, this is B.Tech in any system, in any stream of engineering, or MSc Physics or Mathematics. They can also apply with 2 years of industry experience. And INCOSE, the academic CAB membership will be given, and student individual membership will be given it. And we are having a memorandum of understanding with the Indian chapter of the INCOSE. And the syllabus for the major system engineering courses are examined, and the curriculum is prepared in consultation with the INCOSE India chapter experts. The core courses will have the introduction on the system engineering, multidisciplinary optimization, system thinking and modeling, system of system engineering, engineering system analysis for design, system safety and reliability, introduction of SysML and model-based system engineering, system lifecycle cost analysis, software development for engineering application. And in the allied, there will be, we should need to take some courses on the project management, machine learning, organizational behavior, engineering ethics, and a lot of electives are offered for the student. It is renewable energy sources, introduction to robotics, connected vehicles, aerospace system design, automotive system design, AR and VR, artificial intelligence and the machine learning approaches to design making, supply chain management, ideation of the entrepreneurship. So these are the courses we will be taking in this program. Job opportunities. There are many the industries, both in the government sector and the private sectors. They are these things interested in recruiting the system engineering, like many Indian research organizations, DRDO, ISRO, CSIR laboratories are practicing and encouraging the studies on the system engineering to a great extent. And many of their projects and the programs, they were requiring system engineering trained students. So there will be a very good job opportunities in the many private sector like automotive, power, telecommunication, healthcare, finance, construction, environment, etc. And we have consulted many experts in this area to develop this curriculum. And these courses will be taught by the Mahindra University faculty. We will be having the adjunct faculty from the INCOSE India, We will be arranging the guest lectures by Indian experts, and INCOSE India will be giving us the guidelines. Then they will be guiding train the teachers, framing the syllabus, and the well-known experts in the system engineering is our advisory board of studies. They attended. Dr. Kota Horinaran, you know, he was the chief designer of the light combat aircraft, and he was the program director and of ADA, Aeronautical Development Agency. Later on, after this the superannuation, he took over as the vice chancellor of Hyderabad Central University. He participated in our board of studies, and that given very useful suggestions for framing these courses. And he will be continuously guiding us in this program. Professor Sudhakar, he is a retired professor from IIT Bombay. He was the director of the CASDE, the Center for System Engineering Design and System Engineering Design and Engineering at IIT Bombay. And what is the course learning objectives? You have to develop of the system thinking capability through classical and advanced system engineering theory, methods, and tools. Capability development for the system engineering plan for a realistic project, and just the applicability of any proposed process, strategy, or methodology for system engineering using the fundamental concept from disciplines such as probability, economics, and the cognitive sciences. And we should understand system engineers' roles and responsibilities. We should, at the end of the course, we should understand the role of the organization, apply system engineering tools for that requirement development, management, robust design structure matrix to the realistic problems. We should recognize the value and the limitation of the modeling and simulation, formulate an effective plan for gathering and using data, know how to proactively design and managing the life cycle targets. I have just given a glimpse of the role of the system engineering in the product development, and also the details about the course, what Mahindra University is offering for the student, what is the eligibility criteria, what is the curriculum details, and how we are interacting with the various experts to frame this course. I'll be ending it here. If you have any questions, I'll be very happy to answer. Thank you.